If you are currently leveling up your Django skills with this tutorial, just to let you know, this tutorial is part of a free YouTube playlist, Django Database Structural Testing, where we learn how to set up and utilize PyTest for database structural testing within Django projects. If you like this tutorial and playlist, then also check out our Django Database ORM Mastery course on Udemy. The link to the course and playlist should be found in the video description. Now that we have an understanding of PyTest markers, let's move to the second test, which is to build a structural test to validate the existence of expected columns in each table. Let's remember we have our design, our category table design. It specifies the fields and the field types. So we're going to be building a test to validate, to ensure that what we have developed or defined here within our design is actually implemented with our Django models. Now, you still might be wondering, why would I even do this in the first place? My design is very basic. I can see with my own eyes that it's going to work absolutely fine, and that's no problem. It may be in your scenario, you won't need to actually build this test. But as I've already pointed out, there are a lot of benefits of building these simple tests. And once you have built a test, how we're trying to develop these tests, they are going to be very modular in terms that you could potentially then reutilize the structure of this test, implement it within all the tables in your database, and of course, work with this template then if you then develop any other projects. But another reason to potentially create tests for your Django models and not directly the migration into the database is that this can help ensure that the data, that your models meet the predefined quality standards before it's then loaded into the target system. So in this case, before we migrate our Django models into the database. Creating tests like we are in this module really does help early detection of schema mismatches, which can prevent runtime errors that may occur due to missing columns or incorrect data types. Back in the code, we are back in the test_category file here, module. We have our category table, should you need to reference that when building your test. Right, so we're going to build a test to validate the existence of expected columns in each table and also ensuring the correct data types. So these are all the fields or columns in our table, and we have the data types here also specified. So we're going to make sure that our design meets our requirements. We're going to make sure that our Django model meets the requirements of our design. So let's go back into our test. So in this tutorial, we're going to implement PyTest parameterization. So we're going to bring in the pytest.mark.parameterize. So this is a declarator provided by the PyTest framework. So this is used for parameterizing test functions. It's going to allow us to run a single test function, but with multiple sets of arguments, which will help in efficiently testing various input scenarios without having to duplicate code. We're going to be utilizing this declarator to define multiple sets of parameters. So we need to specify our parameters. So in this case, we're going to be utilizing the field name, or passing in the field name and the expected type. So that is what we want to define right here. It's field name and expected type. So this declarator takes two arguments. It's a string or comma separated parameter names. That's what we're looking at here. And now what we need to do is create a list of tuples, where each tuple represents a set of values for our parameters that we're going to pass into our test function. So let's build our list of tuples. We'll bring this down and we'll use a comma. And let's now build our list of tuples that we're going to be utilizing to pass into our test function. So we need to specify the field name. In this case, the first field in our models. Remember, here we haven't actually specified ID, but Django behind the scenes will create a new field called ID, and it will be an auto field. So we can test for that. So this is going to be, let's put that in the parentheses. So it's going to be ID as the actual field name and then the expected type. So we are going to be utilizing Django model types. So we can specify them like we do in our model. So model dot, and then in this case, the auto field. Now you will need to make sure that models has been imported. So from DjangoDB, import models. So we do want to test for all of the field names and field types. So what we need to do now is add the additional fields into our list here. Now, what's important to remember is that we are developing from a design, not models, although we have already built our models. So it's important not to potentially follow our Django models, but to actually follow the design. Because if you already have made a mistake in your models, if you have created the models first, then you're simply just going to be building a test which will pass the mistake which has been implemented in the models, but doesn't follow the actual design. So try and always make sure that you follow the documentation, the design, when developing your test, if it is available. So we have ID name slug is active level parent, and we have then the field types. Obviously, the parent field type here is going to be a foreign key field. That hasn't been specified here, but that's what it's going to be. So let's go ahead and implement that now in our test. Having followed the design, I've now included all the field names and field types. What you may have noticed in the design is that I have changed it slightly. And the reason why I've done that is really just to try and simulate some issues and problems that you might occur when following such a process. Now that we have our data to be tested, let's now build our test function. So let's follow the naming convention that we have set up previously. So model and a structure test, and then we go ahead and give this a name. So this is going to be column data types. That's the name of the test. And we're going to need to pass in the field name and the expected type. Now, typically with a test like this, we need to actually define the model that we're utilizing within the test. You might like to, or you might prefer to actually specify the model in the data that you pass in. And that way, you don't need to, if you reutilize this code on other tables, you don't necessarily need to forget that you have to also change the test function. So by simply adding a new parameter here, we can just simply go ahead and specify the category table in our tuples here. So we just add that in. So we've now specified the model, or the table, as I keep calling it, and the field name and the expected type. So we just need to change this. Now we're going to pass in the model as well. Okay, so let's finish this off. First of all, we're going to check to make sure that the actual field name exists within the model. Now remember, our models are just classes, so we can work with them in that way, in that we can utilize the Python's built-in functionality to check this object for, in this case, specific attributes. So let's just do that first. So let's go ahead and first of all run an assert. So we're going to assert, and we can use has attribute. So we're going to look in essentially this class, and we're going to check to make sure that the attribute exists or the field exists. So we need to specify the actual object. In this case, it's going to be the model that we passed in. Remember, we're going to take our first list item and run that within our test. So we're going to grab the model, and then we need to then specify the field name. So that comes obviously from our test data here. And then we can also add some additional, don't forget we can also add some additional text should the test fail. So we can use f-string here. So we could say something like, for example, model.name. So we grab the model name. Model does not have, and then we can say field name field. So that's going to be a string which is going to be returned should the test fail. Including a fail string error message for each test assertion might be, in some cases, considered good practice, but it is not always strictly necessary. Whether you should always add a fail string really depends on the context and your specific needs. So let's give this a go, see if this works. PyTest. So run our tests. We're just going to run PyTest. We're just going to run all of our tests. We do have one failed test. Category model does not have level field. Right, so in actual fact, what we've done here is we've run multiple tests. Because remember here, we're utilizing the PyTest mark parameterize. So when we run this test, in actual fact, we are running this test for all of this data here. And you'll notice that we do have one failed test, and that is because we haven't included, because I added this recently to the design, the level field within our model. So we have just really simulated the idea that we've forgotten to add something in our models, and this might be a benefit of utilizing or building the structural tests for our models. So what we need to do, of course, is to go into our models and just make sure that we add our new level field. So this is going to be models.integer field. So we give that a go. So let's go ahead and run our test again. And you can now see that we have 7 passed tests. By all means, just double check to make sure that the category model meets the specification of the design. If you wanted to add the default values here in the level, and it should be not null, which should be the default anyway. So you can go ahead and just add that if you like, but of course we're going to be testing for all of these different attributes. So as and when we get to that point, we'll add them in if you prefer. Now, generally, when writing tests, especially unit tests, it is generally best practice to adhere to the principle of testing one thing at a time. So potentially this test here is just one test. We now build a separate test to test for the field types. In this scenario, I've simply just added the field name and the type into one test. I wanted to show you a second approach to ascertain information in the actual Django model. So here we're going to utilize the Django ORM meta API _ meta to get the field object from the category model based upon the field name. So let's go ahead and create a new, well, let's grab the field first. So from the category table, now we don't need to add the category table here because we have the model. So the model name dot, and then we're going to use the meta to get the field. There we go. So like I said, here we're utilizing the ORM metadata API meta to get the field object from the category model. And that's going to be based upon the field name. So we're going to specify the field name, which of course we're passing in. So we're going to try and grab the field from the Django model where the field name equals whatever field name that we are currently testing for. Right, so once we have that in place, we can now go ahead and have a look at that, inspect that field, and to assert whether it has the correct or matches the expected field type. So let's go ahead and create a new assertion. So we'll use isInstance, is instance. Feels like my fingers are never synced. So field. So we grab the field from the model. So we pass the field in and then the expected type. Okay. So that's what we're expecting. So the field, whatever the field is, and then we check the expected type against the type that's currently been defined within our model. Obviously, this is the type here, so we want to make sure that we build a match. So the name field here should be called name, and then the field type. Expected field type should be models.character field. So we're just testing that against the model that we've already built. So that should then be the same. Right, so with that test in place, you can go ahead, of course, and just add a failed string. Field is not type. And then we can then pass in what was actually passed in. So Like I said, that's completely optional, whether you add the additional text or not. I won't be from this point onwards. That was really just as a demonstration to help you learn a little bit more about what you can achieve, what you can do here in the test. So I won't be adding these failed string messages from this point. In actual fact, you might find it in the source code. I might add it in a little bit later. So let's run this test to see if it works. So from PyTest, and you can see we have 7 passed tests. Now, what we can do is just make some changes just for a little bit of a sanity check. Let's change the field type of the parent field to image field, for example. Let's see if that fails. You can see that has failed. Now, notice that when it does fail, field is not type. So we are returning our error message right here. That can be useful in some instances, but if we look further up, it will provide us more information about where the test has failed. So this is where the test has failed. And you can see here what it's trying to do is provide us with information regarding what the actual output should be and what the output was, to give us a better idea of what it's expecting in order for the test to pass and what was actually provided. So let's just revert that back to foreign key, and then we'll run it again. You can see the test has passed. So we can now feel confident that our model names and data types have been correctly defined for the category model as per specification. Hopefully you can also see that we can easily roll this out now on multiple models. All that we need to do is to change the actual name of the model and the field name and data type. So this is all that we would need to change now to utilize this on other tables that we may have to run tests for. So we have now created a test which will validate the existence of expected columns in each table and ensures that they are or have been assigned the correct data types.